Hello everyone, how are you all doing? So, in this video, we're going to be predicting the percentage of a student based on the number of hours he studies. So, this is a basic data science project, and the concept I'm going to be using for this is called linear regression. Now, linear regression is a relatively simple technique. It just takes one variable and matches it with the other. Now, of course, in multiple linear regression, you will have multiple variables and to find one final answer. But in this case, we're only going to compare one variable versus the other. So I'm just going to show you the data set really quickly. It is hosted in this web browser. And as you can see, the left side shows the number of hours and the right shows the score of the students given the number of hours he studies. So a student studying for 2.5 hours in a day might get a score of 21, whereas contrast that to someone who studies for 7.8 hours in a day and he gets a much higher score of 86. So our aim is to build a model that can predict a student's marks given the number of hours he studies. So basically what I'm using for this, I'm using Jupyter Notebook on my Chrome browser, and I've and for this you'll need the Jupyter kernel, which you can download from Anaconda libraries. And you can also use VS Code. I'll just show that on my desktop for a second. Yeah, you can also use VS Code right here. It's an IDE. I would recommend you using a web browser because it's way faster. And you can also use Google Colab as well. So right now, let's just go through this entire thing. So the aim here is to predict the percentage of a student given his or her hours of study per day. All right. So just to make this a little more neat, I'm just gonna. Right. So just a second. Yeah, so given his or her number of hours of study per day. So now let's look at the steps involved. We need the necessary libraries. So if you have any programming experience in the past, you know you would need libraries to just let the variables do what they have to do. For example, in C++, you would need IOStream or stdlib or string.h or something of that nature. So in Python, the common libraries for data science is NumPy, Pandas, and Matplotlib. And I'm going to explain what these libraries do in a minute. So other than that, we have imported the data set. That is the data set that I just showed you. We're going to import it from this very URL. And we have splitting the independent and dependent variables and making a scatter plot, and tester. So I'm going to explain each and every step as we come to it. Okay. So first step, we import the library. So NumPy is a library that is used to handling arrays. So Python works a lot better when it is dealing with arrays. So that's when NumPy is really helpful for us. Then Pandas is a library that helps handle CSV files and play around with the rows and columns of the array, as we'll see later. And Matplotlib is for various scatter plots, and in this case, we need it for the regression line as well. So next step, we're going to be importing the dataset, which I've got from this exact URL. And as you can see, this command pd.read_csv URL. So whatever data is available in this data set is now saved in this variable over here. Okay, so all the data over here is right over here right now. Okay, so now we have imported the data set, and this command dataset.head just takes the first 10 rows of whatever we have over here. Got it? So yeah, right now we can see the same thing. The first 10 rows 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you should be seeing up to 2.725. Just check that up. Yep. So these are the first 10 rows. Now we are splitting the dependent and the independent variables. So right now we have only one dependent and one dependent variable. The dependent variable being the hours and the independent variable being the score. So if you know anything about basic mathematics, when you have a plot, the independent variable is something. Oh, I think I reversed that. Sorry. The independent variable is the number of hours you study, and the dependent variable is the scores you're getting. So the scores you're getting depends on the number of hours you study. Whereas the number of hours doesn't really depend on anything. You just put the number of hours into work, right? So right now there's a function called iloc in which just splits in NumPy, which just splits all the rows and columns. So iloc stands for ilocate. So it's just finding. So when I put the double quote here in NumPy, I'm taking all the rows. And I'm taking all the columns except for the last column. So there are only two columns here, so I'm taking all the columns except for the last column. The last column is the scores column. Yeah, and over here I'm taking only the last column. So my independent variable, as you can see, I've made an array of all the independent variables, that is the number of hours to study, and excuse me, And for the independent variable, I put all the scores in one array. All right. So now the next step is making a scatter plot between the two relationships. So we're using matplotlib for this. So right now, how to make a scatter plot in Python is pretty easy. Just do plt.scatter. As you can see, I've saved matplotlib as plt. So just plt.scatter will do that. I've chosen my color as blue, so it's clearly visible here. And my x label and y label are my scores and the hours of study. So right now we can just have a look. So yeah, as you can see, so there's clearly a linear relationship between the number of hours put and the score the student gets. So the more the number of hours, the higher the student scores essentially. So now we're going to split the train and test set. So what is the train and test set? So the train set is something we're feeding into the model first. So whatever we feed into the model, it really computes something and then gives us what we want. Whereas the test set is there's a test set is something after the model is trained, the model takes something from the test set and then computes some value. So right now we have this. So from model.selection, so we have this library called sklearn. So sklearn basically has a lot of functions which can really help us, and it has train test split. So what I'm doing is I'm taking 85% of this data set and of this data set, 85% of this is going to the train set. So I'm going to train my model with 85% of this. So normally what we do is we take 80% in in the train set, and the remaining we're going to put in the test set. But in this case, I'm going to take 85% in the train set because we don't have enough data to train it already. So that's what I'm going to do right now. So I'm going to put 85% and my test set size 0.15, which is 15%. Random state initialized to 0 is just as we don't get any random variables inside. So what this random state does is it just takes all the rows and columns just randomly. So I just you know what, I don't really mind which row and column it takes. I just wanted to take some of them. Okay. So X train is going to be all the dependent variables in the train set. Y train is going to be all the independent variables in the train set. X test is going to be the same thing. X test and Y test, same thing with the test set. Okay. Now training the model. So like I mentioned, we are using linear regression. So linear regression is a technique that just maps one-to-one variables and it evaluates how well the model is using the least squares method by determining how far the point is from the regression line, which I'm going to show you in a minute. So this is how I train the model. I call the linear regression function from scikit-learn, and now I'm just fitting the model so as to train it. Now I'm going to plot this regression line on this. So as you can see, I've made the scatter plot over here, and I'm plotting a red color regression line. So I have the X train and the predicted values of the X train. So there you go. Here you have the predicted values of the model, and here you have the regression line. So how it evaluates the error, it just measures each point, how far each point is from the regression line, and then finally gives a value. So if you can see, this is about and then it takes the sums of squares from everything and then gives us a final value. So that's how accurate we are. So to predict the test results, we have a function called linreg.predict, and so yeah, so these are, and we are taking the test values for this. So whatever train values we have, we are getting a score of 16, 33, 74, and 26. So I'm going to compare this with the actual test set. And yeah, as you can see, the actual test set for the same data frame, I'm getting 20, I'm getting around 16. There is a small variation, but the random gist of it is the same. So the actual value of what the person gets is 20, and our predicted value is around 17. Same thing for the second person, it's around 27, the actual value, and the predicted value is around 33.34. Let's just keep it at that. And the actual value is 69, is now 75. And again, so you can see it's not exactly 100% accurate, but it's as close as you get. So to test our model accuracy, I'm going to, there is this function called dot score in scikit-learn. So I'm trying to find the score of the train set. And now I'm just going to print it, and I'm going to round it off to two variables, and boom, we have a 95.16% accurate model. So that means our model is 95% accurate. 95% of the time, it's going to give very accurate values. All right. So now, as you know, in linear regression, it's just very similar to our straight-line formula, as y is equal to mx plus c. So we're trying to find our coefficient and intercept, the coefficient being m and the intercept being c. So just finding that out, we're getting the coefficient around 10 and the intercept being 2.04. Now we're trying to predict the score of a student given that he or she studies for about 9.25 hours a day. So must be a pretty geeky person. So while finding taking the result of this, we're getting around 93.79. So this is how you score well in your test. You study for 9.25 hours a day and you score, and this is how high you score. You're getting around 94%. So in conclusion, model accuracy we're getting around 95.16%, and the percentage of students studying for 9.25 hours is around 93.7%. So that's it. That's all for this video. Thank you all so much.